In this video, I'll explain Gauss elimination method. This method is used to solve system of linear equations. See the first problem. Apply Gauss elimination method to solve the system of equations. Here three equations are given and there are three unknowns. First, we have to write the augmented matrix associated with this system. That is, augmented matrix is denoted in this way, which is obtained by writing the coefficients of the variables x, y, z and this constant term on the right hand side as the rows of the matrix. So take the first equation, write the coefficient of x, that is 1, then coefficient of y along with the sign -2, then coefficient of z 3 colon, just to differentiate these constant values. So it is 2 here. Same with the second equation, 3 minus 1, 4, 4, then 2, 1 minus 2 and 5. This is the first step. First you have to write the augmented matrix. Now we have to convert the part A of this augmented matrix to an upper triangular matrix. Upper triangular matrix means elements below the diagonal must be made 0. The elements below the diagonal are 3, 2, 1. So these elements have to be made 0 by applying the appropriate elementary row operations. There are three types of elementary row operations. One is interchanging any rows or any columns, then multiplying any row by a non-zero scalar k, then multiplying a row by a non-zero scalar k and adding it to the some other row. These are the three row operations available. Now you have to make use of these three operations, any one operation or combination of operations to convert the matrix A into an upper triangular matrix. So the equivalent matrix obtained after the conversion is written like this. Element below 1, they are nothing but 3 and 2. These two elements have to be made 0. I will do R2 changes to R2 minus 3 into R1. So, second row changes in this way. 3 minus 1 into 3. 3 minus 3 gives you 0. So, let me write that result first. No change in the first row, it is as it is. Now second row changes as 3 minus 3 into 1, that is 0. Then minus 1 minus 3 into minus 2, that is like this. Minus 1 minus 3 into the corresponding element is minus 2, minus 1 plus 6, which is 5. Similarly, 4 minus 3 into 3, which is 4 minus 9, that is minus 5. Then 4 minus 3 into the corresponding element of first row is 2. So 4 minus 6 is minus 2. Now this element 2 has to be made 0. So we can go with this operation, that is R3 changes to R3 minus 2 into R1, because 2 minus 2 gives you 0. So we will get 2 minus 2, it is 0. Then 1 minus, it is like this, 1 minus 2 into corresponding element of the first row, minus 2. So 1 plus 4, it is 5. Then minus 2 into corresponding element of first row is 3. Minus 2 minus 6 minus 8. Then 5 minus 2 into 2. 5 minus 4, it is 1. Now to convert this A into upper triangular matrix, now the element below this 5 has to be made 0. So that is possible by applying the operation R3 changes to R3 minus R2, because 5 minus 5 gives you 0. So no change in the first row, no change in the second row. Third row changes as 0 minus 0 is 0. 5 minus 5 is 0, minus 8 plus 5, which is minus 3, then 1 minus of minus plus 2, which is 3. The matrix A is converted to upper triangular matrix. Now the equivalent system is obtained as x minus 2y plus 3z equal to 2, then 5y minus 5z equal to minus 2, then minus 3z equal to 3. That is here x, y, z column wise, and this is constant term. So this system is equivalent to the given system. Now the values of this system are obtained by the back substitution method. Values obtained here are the values of the given system as well. So see here, z equal to minus 1, because minus 3z equal to 3, so z equal to minus 1. Put that value of z here. So 5y minus 5 into minus 1 equal to minus 2. That is 5y equal to minus 2. Here minus of minus plus y, when you take it to the right hand side, you will get minus 5. So this gives y equal to minus 7 by 5. Now this value and z has to be substituted in this first equation. I will write here x minus 2 into minus 7 by 5 plus 3 into minus 1 equal to 2. So which gives you x plus 7 to the 14 by 5 minus 3 equal to 2. So x equal to 2 plus 3 minus 14 by 5. So this is equal to 2 plus 3, 5. 5 minus 14 by 5. When you take LCM as 5, this is 25 minus 14, which gives you 11. So the value is 11 by 5. So hence we got the values of the unknowns x, y, z using the Gauss elimination method.